Topics: octet theory, how ions form, predicting the charge of an ion, writing formulas of ionic compounds, and polyatomic ions, and then writing formulas using polyatomic ions. For the octet theory, we go to the periodic table and we look up the inert gases, or noble gases, which are on the far right. So that's group number 8. They're the only group of non-reactive elements. Now if we take a look at the electron arrangements, we'd see it going like this. Helium with 2, neon with 2 and 8, argon 2, 8, 8. And if we look at the rest of them, you notice that they all end with 8 valence electrons except for helium. So because of this, this gave rise to the octet theory, which stated that 8 valence electrons must make an atom stable because the only elements that are stable, which means non-reactive, in their natural state are the noble gases. So in order for atoms to become like the noble gases, we're going to see that some will lose electrons and some will gain them. So we're going to start off with looking at metals. So metals normally lose electrons when they become ions. Now here's an example with sodium. You notice we have the electron dot symbol with the 1 dot for the sodium atom. It's atomic number 11, so there's 11 protons, 11 electrons, and this is the electron arrangement 2, 8, and 1. Now in order to get 8 valence electrons, it either has to gain 7 or just lose this guy, and then this becomes its valence level, and it has 8 electrons in it. So losing 1 electron is the easier way to go, and you can see that's what's going to happen here. And we wind up then with a sodium ion with a charge of +1, and it has the electron arrangement now of neon. Now if we look at the +1, this is where we get the +1 from. The level of protons hasn't changed at all. That can change because the protons are held too tightly in the nucleus. But the electrons being so far outside and away from the nucleus, they're easily lost or gained. So the +1 is because we have 11 plus from the protons, but 10 negative from the electrons. And if you add up 10 negative and 11 plus, you get +1 for a difference. So we'd see that here if I just did it like this. So we have +11, and we have -10 from the electrons. And if you add that up, you get, +1. Okay, so the +1 is because we have 1 more proton than all the electrons. I'll get back to my arrow here. So, alright. So let's take a look at a magnesium atom now. If you look at magnesium on the periodic table, it's atomic number 12, and it's in row 2. So for a magnesium atom, 2 valence electrons, 12 electrons, 2, 8, and 2, you can see that if it loses these 2 electrons, it'll become like neon, just like the previous example. So here we have now a magnesium ion formed. It has electron arrangement 2 and 8 of neon. It's not neon though, it's like it, being unreactive. And again, +2 charge. And the +2 is for that same reason we saw before. Now we have a +12 and a -10. You add that up, we're going to get a +2 for a difference, and that's why we get that charge. Okay, now let's check out a chlorine atom. So look at chlorine on the periodic table. It's a halogen, so it's in group 7A. And if we look down here, here's the chlorine atom. This is 7 valence electrons. You see the same thing down here, 7 protons, electrons. Now, it's either lose 7 or gain 1. So gaining 1 electron seems to be the easier thing to do, and that's what will happen here. So it gains 1 electron, and now becomes, notice there's a name difference, it becomes a chloride ion. So we went from chlorine atom to chloride ion, and now it has an octet. You see it down here too, and it has a -1 charge because it gained that electron. So you can see 18 negative and 17 positive. Now it has the electron arrangement of argon. Now here's a periodic table showing you some of the ions that we get from the elements. These are ones from the representative elements. So if we start at group 1, you notice that we have all getting positive 1 charge. Group 2 all becoming positive 2. And these positive ions are called cations. You notice that they left out the transition metals because they form different charges and they don't follow the patterns that we're looking for. Jumping over here now, you might wonder, why did we leave out some elements over here? Well, the elements that were left out of this block here normally don't form ions that easily. So they're picking out these 3 guys from group 3, 3A, these 2 from group 5A. Notice how these are the negative ones starting now. So it goes -3, -2, -1, and it'd be 0 here. So all the halogens become -1 when they become ions. Oxygen's family, they all become -2. These 2 guys become -3. You notice nothing much here because they'd have to lose or gain 4 electrons. So normally the elements that we're leaving out don't form ions that easily. Now let's check out some of the names now that we had before. We can see that all of the positive ions, the name is the same name as the element, no difference. But once you get over to the negative side, we have that IDE at the end. You got to make sure you put that there. So we have not nitrogen, but nitride, phosphide, oxide, sulfide, etc. And you'll find these in your book. It should be on page 134. All right, so let's stop here and see if you can answer these questions, then come back and check your results. So how many electrons must be lost or gained by the following atoms to form ions, and then what charge would result? So we have barium, 2A, sulfur, 6A. And then the second question, what's the symbol and charge in the ions with the following electron and proton arrangement? 26 protons and 23 electrons, 35 protons and 36 electrons. So you might want to pause the video at this point and answer those questions, and then come back and check your results. Okay, and here are the results. Barium, group 2A, they lose 2 electrons and get a charge of +2, because now they have 2 more protons and electrons. Sulfur in group 6A gain 2 electrons, get a charge of -2, because now they have 2 more electrons than the protons. Question 2, the ion would be Fe. We get that from looking up the 26 protons, that's the atomic number. And then the +3 is because the 26 protons would be +26, 23 electrons would be -23, and so we get +3 for a difference. And the next one would be Br- or bromide. 35 protons gives us the symbol Br. We have 1 more electron than the protons. It's going to give us a -1 charge. Okay. Now, ionic compounds in general have high melting and boiling points. They're all solids at room temperature. They contain ionic bonds. Here's an example, table salt. So they have very strong ionic bonds. In fact, all ionic compounds are solids at room temperature. There are not any ionic gases nor ionic liquids. And if we take a look at inside a crystal, this is how people picture these ionic solids as looking. We have alternating sodium and chloride ions, and such that they're alternating because of the charge. All we know from the formula, which is NaCl, is that there's 1 sodium to 1 chlorine or chloride, but we don't know how many are in the crystal. We can't tell that by just looking at it. So let's see how we get the formulas for some of the compounds. So we'll start off with sodium chloride. So here we have a sodium atom with its valence electron, and we have chlorine with its 7 valence electrons. Remember the octet theory now. So what's going to happen, the sodium loses its electron to the chlorine, and we wind up with 2 ions formed. A sodium ion with a +1 charge, a chloride ion with a -1 charge. Notice if we add the 2 charges together, we get 0. And that's how we wind up with the formulas for the compounds. So if all it takes is 1 ion of each to give you 0, then that's what we're going to show in the formula, and we get sodium chloride for an answer. We always write the positive one first and then the negative one. Or like you say, the cation and the anion. Also, we wouldn't want to use more than the smallest number. So you wouldn't say, well, I can get 0 if I used 3 sodium and 3 chloride, so couldn't I have Na3Cl3? The answer would be no. These all have to be in the simplest whole number ratio. All right, so let's look at another one. What about for magnesium and chlorine? So here we have a magnesium atom with 2 valence electrons, and we have two chloride atoms, that is, with the 7 valence electrons. So we're going to have the ratio 1 to 2 here, because magnesium atoms must lose those 2 electrons. And chlorine atoms will only gain 1, so it's going to take 2 chlorine atoms to gain those 2 electrons. And so then we wind up with 1 ion, 1 ion, 2 chlorides. If you look down here, a 1 to 2 ratio, and it has to be represented in the formula. So this 2 is called a subscript, and it multiplies directly to its left. So there's 1 magnesium and 2 chlorides. We're not writing in the subscript 1. You notice that it's not showing up in the name, though. This 2 is not in the name. Well, let's look at another one. What about sodium and sulfur? Now, you might want to pause the video and try this on your own, and then come back and check the answer. Okay, here we go. So it's going to take 2 sodiums to 1 sulfur, and that's because sodium atoms will only lose 1 electron, and sulfur is looking to gain 2. So the number of electrons lost and gained have to be equal. That's going to give us 2 sodium ions formed and 1 sulfide. Now our formula has to represent that. So in order to show the 2 sodium, we write Na just once, and then we put the subscript 2 next to it. Remember, the 2 multiplies to its left, not to its right. And notice again, the name does not have the 2 in it. It would be incorrect to say disodium sulfide. Here's the last one we'll look at before we try some quiz. What about lithium nitride? Now here we're already being given the ions themselves. So if you notice, look at the charges, +1 and -3. It doesn't matter that it's lithium and nitride. As long as the charges are +1 and -3, we're going to wind up with the same ratio. And here we go. 3 lithium ions would give us a +3, with 1 nitride ion would give us -3, and we wind up then with Li3N. Net charge is 0. All right, here are a couple of questions for you to answer. So answer these on a separate piece of paper, then come back and check your results. Well, these pairs of elements more likely form ionic compounds. And then the second one, what are the formulas for the compounds formed by the following ions? All right, here are the answers. Chlorine and bromine will not form an ionic compound because they're both nonmetals. We have to have a metal and a nonmetal. And so therefore potassium and sulfur will form an ionic compound. Now what about for the formulas? You notice we have aluminum and bromide here. That's going to be AlBr3. Now you have potassium and oxide. It's going to take 2 potassiums to the 1 oxide. Good. Now for the last one, Ga3, +3 and O-2, it's going to be Ga2O3. Now I want to show you that what we could have done on that, make it even easier. And this works out good. So if I have, I'm just going to use X and Y. If I have X, and let's say it's 3+, and I have a Y, another element, and that's 2- like we had in that example. If you notice the 2 and the 3, the 3 and the 2, the amount of the charge for the first one will become the subscript of the second one, and vice versa. Well, this works out pretty well. It's just that you have to remember to reduce those numbers if you can. And here we have some ionic compounds in their names. And again, you notice the name, it just says what the ions are that are in it. We don't say any subscripts in the name.